Hello everyone, welcome to 10th session on numerical analysis of BSc 5th semester. In this session, we will be discussing about problems on bisection method. In the previous session, we have discussed in detail what are the steps involved in the bisection method. Okay, the steps involved in the bisection method we have discussed very well, and we have also solved one example using the bisection method. That was the previous thing we have done in our previous session. Now in this session, at the end of this session, we will be able to understand thoroughly what are the steps involved in the bisection method. We will become more and more perfect, and we will be able to solve more examples at the end of this session. Now let us consider the next example. Here is the next example. Please try to read the question. Find the positive real root of, look at the question given over here. Here is sin x equal to 1 by x. In the interval has been specified, that is interval a to b. A is 1, b is 1.5, that is specified. So one important convenience we are having in this problem, there is no need to find a and b. They have already been given. Correct to 3 decimal places. That is the question. I have told you in the previous session what is meant by 3 decimal places. Correct to 3 decimal places. I hope you understand very well. Now what is there? The given data is like this, and we have to adjust in the first step. That is, we have to take all the quantities to the left hand side. So when you take it to this side, it becomes minus 1 by x. So the question is sin of x minus 1 by x on left hand side, whereas on right hand side only 0. So this is the equation f of x equal to 0. Therefore whatever is there on left hand side, that we have to take it as f of x. So that's what we have done. So we have taken it as f of x. F of x equal to the entire LHS we have taken. Now given here a equal to the given interval is a to b. So the given interval is a to b, that is 1 to 1.5. Find out the value of f at 1. So the answer is this much, which is negative. And find out the value of f at the next point, that is 1.5. The answer is this thing, which is positive. So we say that when the value of f at this point 1 and f at this point, they are of opposite sign, then we say that the root lies in between 1 and 1.5. The first approximation. Now when we conclude that the root is in between 1 and 1.5, we subdivide the interval 1 and 1.5. So 1 plus 1.5 divided by 2. This is the bisection formula to get the first approximation. So we bisect the interval and we get the first approximated value x1. So after getting x1 equal to 1.25, we find out what is the value of f at that particular point 1.25, that is x1. Now the answer is 0.14898. I request you people, I tell you people to use the scientific calculator in a better way. See, always your calculator will be in degree mode. So whenever you deal with the trigonometric functions, you first change the mode of your calculator to radians. That job you have to do at the beginning. So change the mode of the calculator to radian and then start working with the trigonometric functions. Whenever trigonometric functions arise, you change the mode of the calculator from degrees to radian. So it should appear as R at the top bar in your calculator. That you have to be that you have to ensure. So now we have obtained f at x1 as positive. Earlier, if you look at, you please look at these two values. See, f value at 1, it was negative, and now f value at x1, that is 1.5, is positive. We say that the root is in between 1 and 1.25. So the root is in between 1 and 1.25. We are concluding like this. So when we conclude like this, after that what we have to do? We have to subdivide that interval 1 to 1.25. we have to use the same formula. We have to use the same formula, bisection formula, this plus this divided by 2. So that is the formula we are using, and we are getting the value of x2 as 1.125. Previously it was 1.25. Now the new value is 1.125. So the interval is now shortened again. Now we have to find out the value of f at this point, f at x2, f at 1.125. If we evaluate, the answer is again positive. When the answer is again positive, you please try to have a look at this. I once again take you back to the values which we obtained in the first step. Here we got f value at 1 as negative, and later on we got this as positive, and f value at even 1.25 as positive. So now the new value which we obtained is, you please try to have a look. The new value which we obtained here is this thing is positive. So therefore the root is in between 1 and 1.25. We can conclude that the root is in between 191.125. So the root is in between 1.25. Okay, now again you have to subdivide this interval. That is the thing we have to do. So let us subdivide the interval 1 and this thing. We have to subdivide this. We have to bisect this. In order to bisect, we use the same formula. This is the formula over here, and after that we get x3. x3 value is this thing, 1.0625, and observe the value of f at that point, this point. Again we got it, in this case we got it as negative. When we get it as negative, then what we have to do? We have to conclude that the root is in between this and this. Okay, the root is in between. You please observe, I have written a statement over here that statement is, since the value of f at this point and the value of f at this point, they are of opposite sign. When they are of opposite sign, we conclude that the desired root lies in between these two things, and then we subdivide this interval again. When we subdivide this interval once again, we get the new value x4. New value x4 is computed like this. So once again we have to see what is the sign of, and we have to be careful here whether the value of x4 and x3 they are same up to 3 places of decimal or not. If not, we have to proceed. So that's what we are doing. We are proceeding further because they are not same. You can observe. What was x3. X3 was 1.06, but x4 is 1.09. At the second decimal place itself, the answer is different. So therefore it is not our answer. We have to proceed further. So we have to go on improving the values as I have explained you in the previous steps. You do the same type of work, and at the I will tell you, at the 11th iteration, the 11th approximated value is going to be 1.11405, and we find the value of f at this particular point x11. So the value of f at x11 is going to be negative. And we observe that the value of f at x11, that is f at 1.11405, and the value of f at 1.1143, which we obtained in the previous steps, that value and this value, they are opposite signs. They are having the opposite sign. When they are opposite, we say that the desired root lies in between these 2 points. See, the root lies in between these 2 points. When the desired root lies in between these 2 points, what is the thing we have done? We have contracted the interval to a very, very, very smaller extent. Now we are going to bisect this smaller interval again, and that bisection gives us the new approximation that is x12. X12 is now turning out to be this much, 1.114175. Now you observe please, up to the 3 places of decimal, the answers which we got in 2 consecutive iterations, they are same. 2 consecutive answers, that is one is x11 and another one is x12. These are the 2 answers. x11 is 1.114, x12 is also 1.114. Up to 3 places of decimal, both are exactly same. So we can say that x11 and x12 are same up to 3 places of decimal. Therefore, we can say that this is the solution which we obtained is correct to 3 decimal places. So what was the question? The question was the same thing, that is to get the solution correct to 3 decimal places. That's what we obtained here, and we can say that the 12th iterated answer is the final answer. Therefore, we can stop at this point. We can stop at this point, and whatever answer we get in this step, we can take it as a final solution. So this is the answer. Hence x is equal to 1.11417. It is actually, you can round it off to 1.1142, and you can say that this is the desired root of the given equation. So this is how the bisection method proceeds, and I hope you understood very well how to solve the examples on bisection method. With this, let me conclude, and I request you people to solve this problem correct to 3 decimal places. The answer is going to be this thing. This is an assignment for you. You please try to solve this book, and there are many more examples. You please try to have a look at this book. Again, you please refer this book and try to solve more and more examples. With this, let me stop. Thank you very much.